Hello everybody. Thank you so much for joining us today. I know that there's a lot of places you could be right now, but you chose to be here with us, and I appreciate that. Now, we don't have a lot of time, so let's dig right into it. What we're going to talk about is reactive programming with RSocket. Now, you've probably, hopefully, heard about RSocket. RSocket is a protocol. It's a binary protocol that was developed by engineers at Netflix, who then went to Facebook. The protocol serves to support reactive stream semantics on the web, on the open internet, and the benefit of that is that you get things like back pressure, you get things like you get operations-minded features like metadata, you get lots of things that you want when you build production-grade services. It's also payload agnostic, so it's binary data for both the payload and the headers. It is a very flexible protocol in that it supports a number of different message exchange patterns, request response, fire and forget, things like that. And there are a number of different bindings for it because it is a network protocol. So you can use it from Java, from JavaScript, from C++, etc. Now, in the very beginning, there were several different implementations. One for Java that was based on Reactor. Now, Reactor, of course, is what supports the reactive APIs in the Spring ecosystem. And so, my friends, that's what we're going to look at today. Is we're going to build a service today using the RSocket support, using Lombok, and using Spring Security. So we're going to go ahead and build a new project here at start.spring.io. We're going to use Spring Boot 2.3x. It doesn't matter which version of 2.3, but 2.3 is very nice because it has, among other things, it has new support for building or for building more cloud-native applications. So easy Docker image generation based on Spring Boot 2.3, easy features for Kubernetes, things like availability endpoints and things like graceful shutdown of services that are running inside of a containerized environment so that in-flight transactions get get finished and then they're given a chance to shut down gracefully. All sorts of very useful features. One of my favorite things that's now a possibility is to use Spring Boot 2.3 with Gravim. Gravim is a ahead-of-time compiler. Actually, it's a just-in-time compiler. It's a C1 replacement, basically, for OpenJDK or other standard JDKs like that. But you can use one mechanism, one feature in Graal to support ahead-of-time compilation. And that ahead-of-time compiler is called the Gravim Native Image Builder. And the result is much lighter weight builds and much faster startup time. So here's some traditional Spring Boot applications. And I don't have enough time to show you all these things, so please go on the internet and see my videos. Look for Josh Long and Spring and Graal. But these are Apache Tomcat and Spring Data JPA with Hibernate, very, very slow kind of technology, right? So I go to Target Native Image, and then I just run the native image, and you can see that it starts up in 0.3 seconds. Actually, that's pretty slow. There you go, 0.169, right? Pretty good. We can go to the Mongo example, like this, cd MongoDB, cd target native image, and here you can run MongoDB, and the MongoDB example starts up in, about 1/10 of a second, 0.1 seconds, and then of course you can go back to the reactive one. Now the reactive one supports SQL-based data access as well as a web server, a reactive web server as well. So target native image, and then reactive, and Control C. Okay, take 2. So that's 0.089, right? Pretty good. And we can go here. Localhost customers. Oops. There. Okay. So there's our endpoint. Control C this to stop it. So yeah, lots of reasons to use Spring Boot 2.3, but that's not what we're here to do. So let's ignore that for now and build our application. So what we're going to do is we're going to build a new service using these dependencies. I'll generate it, and we'll open this up in our IDE here. Okay, So the first thing that we want to do is to comment out the dependencies that we don't need. So I'll go down here and I'll just comment out the Spring security dependencies for the moment. We'll come back to them later. Okay, so I'm going to re-import the build. Then I'll go to service application. And here, I'm going to build a simple controller. Now, I'm going to build a Spring messaging controller. The controller will be a greetings controller. Okay, a greeting controller, and it in turn will return a stream of responses and requests based on requests. So, given a request, I'll return a message. Okay, and of course, in languages like Kotlin and Scala, they have convenient ways to turn these Java objects into things with properties and getters and setters and toStrings and so on. But in Java, we don't really have that. So until Java 14 records arrive, so I'll use this instead. And we're going to create a simple endpoint that we're going to map to an RSocket route. Now, routes are not supported in the raw RSocket protocol, but they're easy to build here with Spring support. So I'm going to build an endpoint that takes a single request in and returns many responses out. A flux takes 0 or more records. I could also do just one record. That's a mono, right? And one of the nice things that's really convenient about RSocket is it supports many different message exchange patterns. So fire and forget, request response, it supports request stream, and it supports channel. Okay, so a fire and forget looks like this, right? No response. Request response looks like this, where you have a single value to come in, or this. This is the same thing, mono, right? And a request stream is a single value to come in and multiple values to go back out. And channel is multiple values coming in and multiple values going out. So lots of different message exchange patterns. Remember, HTTP only supports request response. There's no other way to do it. The client has to initiate it. The other thing that's nice about RSocket is that, as you'll see, the service starts up and it stays up, and then the client starts up and it stays up, and they stay connected, right? So once these things are connected, they no longer need to negotiate the constant, network connection and handshake and all that. We can just make requests and not worry about reestablishing all that information. Okay, so we're going to do a request stream example here. And what I'm going to do is I'm going to create a reactive stream using a Java 8 stream. So I'll say generate using a supplier, and I'll say greeting response, and we'll say new greetings response, and I'll say ni hao request dot get name at instant dot now. Okay. Now that's going to be an infinite stream, and what I want to do is I want to turn that into a reactive stream. So I'll just pass that into there, and I also want to slow it down so we can see what's happening. So I'll use delay elements to stagger the results, to slow them down just a little bit. Okay. Here we go. So there's my greetings endpoint. Now I want to talk to this endpoint, but well, first we must start it up. And in Spring Boot, if you want to start up an RSocket endpoint, you just use the RSocket port property. Okay, so here is the property. I'm going to use 888. That's a nice good luck number. Start that up here. And now I can talk to it using a very handy utility on GitHub by Maki-san. It's called RSC. It was built by my friend and colleague Toshiaki Maki. He's a colleague at VMware, and he built it as a CLI to support RSocket. It's kind of like curl for RSocket, and it's very convenient. So let's use that here to make a request to our service. So we'll say RSC TCP. Now this is important because RSocket speaks. You can run RSocket on top of many different protocols. It can be TCP, it can be Aeron or WebSockets or whatever. Here we're saying that we're expecting not a request response, but a request stream. So that's this. We want the route to be greetings. we want to log the output and then debug the reactive calls, and the data that we send will convert from this, right? So data name Josh, let's say, okay. Now of course I need to escape the quotes here. Alright, and if I do that, you can see I'm debugging the results, so I can see the message frames and the payload itself, and I can see the reactor callbacks, the on-next methods, and I can see the payloads, ni hao, Josh, every second, okay, forever. So that works, right? That's easy. I can prove that it's working this way. But I want to build a client to actually talk to that service. So I'll go back to start.spring.io, and we'll build a client, okay, to talk to it as well. And we'll generate that. And we'll open this up. And the client is going to talk to the downstream service. So we'll create a simple bean, a component. Actually, here it's better this way. A bean, application listener, application ready event. Okay. Return arguments and application ready event. Thank you. And in order to talk to the service, we need an RSocketRequester. Now the RSocketRequester, you need to construct it and point it to the service at startup time. So here, I'll tell it to find localhost 8888 using this builder. Okay, and we can configure all sorts of things about the application with this builder, but for now that's okay. Okay, we'll leave it like this. So RSocketRequester.builder, and here I'll say that I want to use my RSocketRequester, right, like so. I'll say client.route greetings, and the data that I want will be I'm going to send a new greetings request in, but of course I don't have the type called greetings request, do I? So I need to copy and paste this type from over here. So I'll go here and I'll take the DTO, the entities, and we'll go back here and return it. Okay, so greetings request, and the name, it could be anything, right? So Alibaba. Alright, there's our name, and the data that we expect to come back will be of type greetings response. So if I assign this to a stream, then I get a publisher of greetings response, right? And of course I can log out the results, system out print line. Alright, good. There we go. There's our simple client. The only thing to keep in mind is that if I start this program, I'm not starting a RSocket service, and so my RSocket service, my RSocket client, will start and then immediately stop because there's no daemon thread keeping the Java application open. So I'll just read in a single character here before I run the client. Okay, let's run it. Okay, so there you go. You can see here it's saying ni hao, Alibaba, every second, forever. It's reactive, right? Now, this wasn't so bad, right? I was able to point it to the route. I can even do route variables, right? I can do that kind of thing. I could point it to the route, and then I could easily just send data in, and then I could easily get a stream back. And so it maps very nicely. It's very easy to build a client for services if you want to build a Java object. But we on the Spring team have started something experimental, and maybe it'll be useful to you. You can try it out. It's called Spring RetroSocket, and it's a Feign-like RSocket client, very simple, and it's not GA. Okay, it's early. It's not yet ready for production, but very simple. You can create an RSocketRequester, @enable RSocket client, define the RSocket client interface, and then you're done, right? You can actually map the interface methods to endpoints on the service, and it'll automatically give you a working object, an instance that'll actually make those calls for you. It could be very convenient, I think, but I would welcome your feedback and your pull requests and your ideas and so on. Now, we have a simple service here, and I'm using the RSocket client. That's one way to do this, right? I have an infinite stream here. Let's limit this to just a few, okay, 10 records, let's say, so that we can see what's happening in the next demo. So I'm going to now restart this, and sometimes, by the way, I notice that you have to force this. You have to click it and then force it to restart. I don't know why. Sometimes IntelliJ doesn't kill the process. So what we're going to do now is we're going to take a look at using RSocket from Spring integration. And the reason that we want to do this is because it's very common that we have non-reactive services with which we need to integrate, but it would be very nice to then bridge that non-reactive code with reactive RSocket-based code. And Spring integration gives us a very nice component model for integrating things that don't want to talk to each other, right? Now, keep in mind, you can already achieve some of this if you're willing to manipulate schedulers and so on at the lower level of Reactor. But it's just nice to have Spring integration, because Spring integration gives you a pipes and filters component model. So I'm going to build a integration application. I'll hit generate, and we'll go to the downloads directory, integration.zip, open this up, and when I open this up, I'm going to start writing some code using Spring integration. Now, Spring integration has a component model based on the ideas from the amazing book by Bobby Wolf and Gregor Hoppe, right? This is Gregor Hoppe. Great book, and I recommend you read the book. It's called it's the Patterns of Enterprise Application Integration, and in the book they talk about many different patterns to support integration. How do you take one service and system and make it talk to another? So there's a lot of different things you could use here, a lot of different ways you could do this, but if you write your code using messaging components, then it becomes very natural to string together or recompose these messaging frameworks, right? So I'm going to bring in two modules, Spring Integration File and Spring Integration RSocket. These give me components that I can use to talk to the outside world, to talk to external systems like the file system and like RSocket. There are many different components, but in Spring integration you have inbound adapters and outbound adapters. Outbound adapters take Spring Framework message and turn it into something in the real world, right? Inbound adapters take the real world events and turn it into a message. Okay. Once you have the message in the system, then you can do things with the message. You can split the message, you can route the message, you can transform the message, you can enrich the message, you can wiretap the message, you can what else can you do? You can aggregate the message, right? These are all patterns from the book. Sometimes it's not enough to use just one direction adapter. Sometimes you want to take a real world message, send it to Spring integration, and then send a response out back to the real world. This is a inbound gateway. And the opposite is true as well. You can say, maybe I want Spring integration to generate a request to the real world, and then the real world will send back a response to Spring integration. This is called an outbound gateway. Okay, so these are request and response basically, whereas this is just send a message or receive a message. It's one direction, and then in between you can do things like this, right? So lots of different possibilities, lots of different patterns. These components are reusable. If you do your job correctly with Spring integration, then a lot of what you will do is just taking existing things and using them to build solutions. So let's build a simple integration that supports file data piped to a RSocket endpoint, piped to output. Okay, we're going to just compose these things in this way. So we'll create a Spring Bean, an integration flow, RSocket flow. I'm going to say integration flows dot from, and what we're going to do is we're going to create a file inbound adapter equals files dot inbound adapter var file or folder equals new file, and we're going to inject Spring. We're going to have Spring inject the home directory here, home. Okay. We'll say home desktop and create a new file, and it'll be in. Okay. Now the inbound directory is, the inbound adapter will monitor this directory. It'll make sure that if there's a new file, we are given an event. Okay. So it'll monitor that. We want it to create the directory, and that's it. I guess that's all I care about. So we can then use that file inbound adapter, right? There you go. We can use that, and we can then do things with it, right? We can do all sorts of things with it. But the problem is that file systems, they don't have any way to tell us what they want. And so we must configure some way to ask over time what the file system is seeing. So we can configure a poller, okay? And so we say pm.metadata fixed rate. And here, what I'm saying is I want to scan the file system every second. And as soon as there is data, then I will take that data and I will process it. And what I'm going to do with that is I'm going to take that data that comes in. It's a file, right? It's a Java IO file. So I'll create a new file to string transformer, and then from this string, I'll create a name, right? I'll assume it's a name. So new greeting request. But the problem, of course, is we have no greetings request on the class path. So let's go back to our code and take these two types as DTOs, and we'll paste them in here. So greetings request. Now name.toString, all right? And then from this, sorry, I want to do a trim, not toString. From there, I'm going to then call the RSocket endpoint, right? So var RSocket equals RSocket's outbound gateway, okay? And so the endpoint is called greetings, just like we saw before. The interaction model is called request stream. The client RSocket connector is a bean that we must define that tells Spring and tells RSocket how to connect our application to the service. Now, we could also provide an RSocketRequester, but this is very convenient, so we'll do this, right? Because it gives Spring a little bit more information. So new client RSocket connector, localhost 8888, CLC, and we also need to provide the RSocket strategies. So RSocket strategies. All right. There's this strategies. Return CLC. Good. So there's this. Now we're going to inject this bean here, connector, and we configure that as so. And the other thing that we need when we configure the RSocket outbound gateway is the expected response type, right? We want to know that it's a greetings response. So there's the entire thing, okay? Pretty consistent. So this is file inbound adapter, RSocket, RSocket outbound gateway, and here are some of the components, right? Transformers, handlers, etc. Now we're going to send this to RSocket. So this is going to send this message, which is a greetings request, to the RSocket gateway. When the response comes back, I will get, if I write this code honestly, what I will get is I will get a publisher of greeting response, like this. Well, I don't want a publisher, right? I don't want this. I want just this, not this. So what I want to do is to split it, okay? But the problem is that when I split it, I'm also subscribing, and I'm subscribing to a reactive response. And so I want to make sure that all the components after split understand back pressure. So I will create a message channel, like so. Reactive message channel. Return message channels dot flux dot get. Okay, so there's this, and we say channel reactive message channel. Okay, now this code is now different. I'm not going to use flux here. I'll just use greetings response. Okay, and I can just log it out. So I'll just say system out new message greetings response dot toString. And in Spring integration, when you return null, that tells Spring integration to stop processing. Okay, so otherwise we're done. We have done everything we need to do. So let's run this code. Okay, so now we go to the file system, cd desktop in echo world, or yeah, let's just do Spring name, and then here you can see it says ni hao Spring every second, going on and on and on. Okay, so that's another kind of client, another way to work with it. There's also an inbound gateway, so you can act as a service. And this is actually, everything we have done so far is one direction. The data comes in, we process it, and we send a response. But RSocket is bidirectional, and this is one of the really interesting powers of RSocket, is I can do things bidirectionally. So let's do that. Let's actually change our example a little bit. In this client, I want to also have a controller. Okay, so I'll create a health controller, and the controller will have a message mapping endpoint, health, class client health state, private boolean healthy. Okay, now this will just be information that we will serve for whoever wants it, so that they can know if our client is healthy. Okay, and if they're not healthy, then we can stop serving, the service can stop serving data to us, right? That's very useful. So here I'll just create a simple stream as before. Stream.generate new supplier, new client health state, and we're just going to create some arbitrary sort of random health status. So greater than point. So we're going to be okay if math.random is greater than 0.2, right? But that means that sometimes we're not going to be okay. It'll be false. So, and then of course we're going to stagger this. So this goes here. Dot delay elements, duration of seconds 1. Okay. And what I want to do is I want to make sure that when somebody connects to this service, to this client, when the client connects to the service can ask the client, hey, is your service okay? Is your telemetry okay? If so, here's some data. Are you okay? Here's some data. Are you okay? Here's some data. But if it becomes sick, if it becomes unable to continue processing the results, then we want to make sure that we stop bothering to send data that it cannot work with, right? So this is a very simple example, but it's pretty easy to see how useful this will be. So what we're going to do is we're going to create a socket acceptor, okay, and we're going to use RSocket message handler dot responder, RSocket strategies, and we're going to inject the health controller as well. Strategies, health controller. Okay. Now this socket acceptor we can configure on the RSocketRequester itself, right? So acceptor, right? Like so. Oops, it's a acceptor, I think. Builder dot there we go. Okay, and we'll inject our socket acceptor here. Okay, good. So that's all that we need to do on the client side. Now, on the service side, I want to change this code so that when the client first connects and makes this request, we can ask the client how healthy it is. And we're going to do that by injecting a reference to the client RSocket connection. Okay? So there's this, and we can use that. We can say, okay, let's clean this up a little bit here. Var out, okay, that's a reactive stream, but the data that is coming in is from the client RSocket connection, from the health endpoint, and we're going to expect a stream of client health state.class. But of course, we have to go get this type from the client. So here it is. Okay. Good. So there's this. Okay, now what we want to do is we want to say, okay, return out, but only when there is an unhealthy, only when the data is healthy, when the client says that it's healthy. So we're going to filter CHS. We're going to keep it if it's not healthy. So if it's healthy, then this is empty, right? If it is unhealthy, we have one element, right? We have a client health, client health state healthy equals false, right? So that will only happen once. As soon as that happens, not empty, right? As soon as it's not empty, then this out will stop producing data, okay? So let's restart this service. Okay, and we can go to the client and restart that. Okay, and so you can see on the left we've got data, and it stopped, right? At some point, it got to an unhealthy response, and it just stopped producing data. So this is very powerful. Now, a very common question that people ask is, can I do security? Well, of course you can. And so what we're going to do is we're going to use Spring Security to lock down our service. I have those dependencies here. I'll go ahead and just reinstall them. Okay. There we go. So I'm going to bring in Spring Boot Starter Security and all of this. And I have to answer a few questions, a few concerns. I have to create a security configuration class. Security configuration. And the first bean that I need is authentication. And I'll just create a user. JLong password roles user.build. Okay, so there's my authentication. And I want to also care about authorization. So authorization limits how much access I have, right? So RSocket security, and I'm going to say return security.build. I want to lock down everything, so I'll say ap.anyexchange.must be authenticated. I want to use simple authentication, but you could use JWT if you wanted as well, right? That's another option. I won't use it here, but you could. Okay, so that locks down everything, but I want to change my example a little bit so that instead of getting the name from a greetings request, we get it from a authenticated principal. So it'll be the same basically, but the user will be authenticated, and we'll use that information to determine who we should greet in the response. Okay, so we say authenticated principal, and here user dot map ud.get username dot map user name new greetings request, and then flat map mini gr this.greet. I'm going to pass in the client RSocket connection, GR. Okay. Let's see. Oh, this. There you go. Okay, so I'm just reusing the existing endpoints, and we're just going to take this one out. We don't want that one publicly accessible anymore. Okay, so now we have the same basic functionality, except that there's no greetings request anymore, right? We're going to have just the current authenticated user. The thing is, this annotation doesn't work unless you configure it in Spring Security. So I'm going to create a RSocket message handler, and var rmh equals new RSocket message handler, rmh.get new authentication principal, and then we have to set the strategies as well. So I'll say RSocket strategies, like that, return RMH. Alright, that's it. That's the entirety of our service. Let's restart this. Okay, and on the client, we must connect to that service as well. Now, is it okay? Yep, it's up and running. There's the service. Here's the client. We need to change the client to be authenticated now. And so I'll do this easily by just using my hard-coded username and password. Okay, so credentials, username, JLong, PW, and the MIME type. So in RSocket, you have this concept of metadata, and it's like headers, but each header has a MIME type, a content type. So I need to specify that we want to use the well-known MIME type there. Once I have done this, then I can configure the authentication a couple of places. I can do it as part of the setup information here, or I can do it in the request itself. So obviously this no longer needs to be there. I can do mono.empty, and I can do .setup, sorry, .metadata, this .mime type. Okay. The only other thing that I need to do is I need to teach RSocket how to encode the metadata for security. So RSocket strategies customizer strategies dot encoder new simple authentication encoder. Okay, so there's the client. Let's go ahead and restart it. And there you go. It says JLong. All right. Thank you, everybody, for watching this. I appreciate your time today. I know that it is sad that we could not be together in person. I hope next year that we can be together in person. Thank you for your time. If you have questions, I'm happy to answer them. You'll see my information and my email and so on at the end of this presentation. Thank you.